46 years. That is the length of time a small machine built by humans has been moving through the darkness of space, drifting farther and farther away from everything we have ever called home. For 46 years, it has traveled in near silence, while its systems slowly grew weaker. Its power has been fading. Its instruments have struggled to remain alive. And then, after nearly half a century of flight, it crossed a boundary no human technology had ever crossed before. What sent back 4 scientists to ask a question they were never prepared to confront. What if everything we call home has actually been protected by a shield? Most people imagine space as empty, quiet, and harmless, a vast void stretching between the stars. But when Voyager 1 crossed the invisible boundary of our solar system in 2012, its instruments revealed a very different reality. They showed a sharp division between 2 environments. On one side exists the realm of our sun. On the other lies the raw power of the galaxy itself. The transition was not slow. It was not gradual. It was as sudden as flipping a switch. And what Voyager discovered beyond that switch confirmed something deeply unsettling. Our solar system is not peacefully floating through space. It is fighting to survive. The moment the boundary was crossed, when Voyager 1 reached the outer limit of the sun's magnetic influence, something extraordinary occurred. The spacecraft crossed a boundary known as the heliopause, the point where the solar wind can no longer dominate and the pressure of the galaxy begins to take control. For decades, scientists had predicted this transition, but until that moment, no instrument had ever measured it directly. When the crossing finally happened, it did not resemble a gentle blending of 2 environments. It was abrupt, sudden, almost violent in its clarity. Particles from a solar wind suddenly dropped off. They nearly disappeared. At the exact same time, high-energy cosmic rays from the galaxy surged inward as if a door had just been opened into a chamber filled with radiation. Waiting outside, there was no smooth overlap, no gradual fade between the 2 regions. One moment the sun dominated. The next moment the galaxy took over. This was not symbolic. It was physical. It was measurable through particle counts and magnetic field data. A boundary where the rules changed instantly. And that discovery forced scientists to rethink how the edge of the solar system is defined. For decades, people imagined that the end of the solar system was simply a matter of distance, the orbit of Neptune, the Kuiper belt, or perhaps the distant Oort cloud somewhere far beyond. But Voyager revealed something different. The solar system does not end because of distance. It ends because of physics. Our system stops where the solar wind can no longer push back the galaxy, where the magnetic influence of the sun loses control and galactic forces begin to dominate. That is the real border. Invisible to telescopes, impossible to photograph, detectable only through particle behavior, plasma motion, and magnetic fields. Voyager proved that this boundary is not theoretical. It is real, sharp, measurable. On one side, solar particles dominate. On the other, galactic radiation floods inward. 2 completely different cosmic environments separated not by emptiness, but by a thin and dynamic membrane, where neither side fully wins. And what Voyager discovered beyond that line revealed something even more disturbing. The solar system's protective bubble. For most of modern astronomy, scientists imagine the heliosphere as a massive magnetic bubble inflated by the solar wind, a protective sphere stretching millions of kilometers in every direction, a stable shield separating our solar system from the rest of the galaxy. But the data from Voyager told a far less comfortable story. The heliosphere is not perfectly round. It is compressed on one side and stretched out on the other. It is distorted, asymmetrical, and constantly responding to forces from outside our solar system. and that external pressure is stronger than scientists once believed. Voyager measured a density of interstellar particles higher than predicted. That means the galaxy is pushing against our heliosphere with enormous force. Invisible pressure, but immense. Millions and billions of tons of galactic material pressing inward against the magnetic influence of our sun. This boundary is not passive. It exists because of a continuous struggle. Every second the sun pushes outward with charged particles expanding its magnetic territory, and every second the galaxy pushes back. The heliopause, the line Voyager crossed, is the narrow region where those two forces meet, where neither one fully wins. That realization changes how we think about our place in the universe. Our solar system is not quietly drifting through empty space. It is resisting compression. It is maintaining territory against a much larger galactic environment. And if that external pressure were to increase, if our sun moved through a denser region of interstellar space, the heliosphere could shrink. If that happened, far more cosmic radiation could penetrate deeper toward the inner planets, including Earth. Our home is not isolated. It is defended, a living boundary. People usually imagine shields as solid walls that never move. But the heliosphere does not behave like a rigid barrier. It behaves more like a living membrane. It expands and contracts depending on solar activity. When the sun releases more energy, the boundary pushes outward. When solar activity weakens, the shield shrinks inward. The edge of our protection breathes. Voyager's measurements revealed that the heliopause is not calm or quiet. It is active. Solar wind particles do not simply disappear when they reach this region. They slow down, compress, heat up. A dense layer of high-energy plasma forms where solar particles collide with the interstellar medium. Temperatures there rise far higher than scientists once predicted. Energy builds up. Pressure increases. This is not a peaceful handoff between two environments. It is a collision zone where two different cosmic regimes meet and interact. The heliopause behaves like a filter. Particles from the inside are modified before leaving. Particles from the galaxy are partially deflected before entering. It acts as a mediator between our star and a larger galaxy, and that interaction has enormous implications for humanity. Every mission to the moon, every future journey to Mars, every deep space expedition, all depend on understanding how this boundary protects us from cosmic radiation, a strange magnetic discovery. Scientists once believed the boundary between solar and galactic magnetic fields would be chaotic. They expected twisted magnetic lines and violent turbulence as two enormous systems collided. But Voyager revealed something unexpected. The magnetic fields on both sides of the heliopause were almost perfectly aligned. Instead of violent turbulence, there was a surprising continuity. Instead of chaos, there appeared to be synchronization. The magnetic structures of our sun and the galaxy seemed to adjust to each other rather than clash. No one had predicted this. Particle conditions changed abruptly at the boundary, but magnetically the transition showed an eerie similarity. Scientists expected conflict. What they found looked more like cooperation, and that raised a profound question. How can two magnetic systems born from completely different cosmic sources align so closely at their boundary? The answer remains unknown, but it revealed that the relationship between our star and the galaxy is far more complex than we once imagined. Redefining the edge of home. Voyager's discoveries forced scientists to rethink the very definition of the solar system. For generations, we believed our system ended where the planets stopped. But Voyager showed that the real border is not where objects orbit the sun. It is where the sun's influence ends, where its magnetic shield can no longer hold back the galaxy. That is the true frontier of our cosmic home. 446 years, a machine built with 1970s. Technology traveled farther than any human creation ever had. Its computer is weaker than a modern smartphone. Its power supply is slowly fading. One by one, its instruments are shutting down. Yet before falling silent, Voyager 1 gave humanity something extraordinary. It showed us that the edge of our solar system is real, sharp, measurable, alive. It revealed that our home is not simply a region of space defined by planets and orbits. It is a magnetic shield pushing back against the enormous pressure of the galaxy, a protective bubble constantly under compression from invisible cosmic forces. Beyond that boundary, radiation surges. Galactic cosmic rays dominate. Magnetic authority shifts. The rules change. There is no gentle fading into emptiness. There is a line. On one side, the sun protects us. On the other, the galaxy takes control. And that realization changes how we see everything. If this discovery changed the way you think about space, make sure to subscribe and stay with us. Because Voyager may be approaching silence, but the story of what lies beyond our cosmic shield has only just begun. But the story does not end with the boundary itself. Because once scientists began studying the data from Voyager 1 in detail, another realization slowly emerged. The heliopause, the border between our solar system and the galaxy, does not just mark a frontier. It records history, the boundary that remembers. When we think about space, we usually imagine events happening instantly, but the solar wind does not reach the edge of the solar system right away. It takes years for particles ejected from the sun to travel billions of kilometers outward before finally arriving at the heliopause. That means the conditions measured at that distant boundary do not represent the sun as it is today. They represent the sun as it was years ago. The compressed plasma, the magnetic structures, and the particle flows detected by Voyager are delayed echoes of our star's past behavior. In other words, the heliopause behaves like a cosmic archive, a record written in plasma and magnetic fields. Every surge of solar activity, every powerful eruption from the sun, every fluctuation in the solar wind, all of it eventually reaches the outer edge of the solar system and leaves an imprint there. The boundary remembers. For scientists, this discovery transformed the heliopause from a simple border into something far more profound. It is not just a frontier. It is a living historical record of the relationship between our star and the larger galaxy, a constant cosmic struggle. The data from Voyager also confirmed something that had only existed in theory before. Our solar system is constantly under pressure. The galaxy itself pushes inward against the heliosphere from every direction, and the sun pushes outward to resist it. This is not a gentle interaction. It is a continuous cosmic struggle. Every second, billions of charged particles stream outward from the sun, forming the solar wind. Those particles carry the sun's magnetic field far into space, creating a vast protective region around the planets. But beyond that region lies the interstellar medium, a sea of particles and magnetic fields that fill the Milky Way. And that environment is not quiet. It is filled with plasma waves, magnetic currents, and high-energy radiation produced by violent cosmic events. Among the most powerful of these events are supernova explosions. When massive stars collapse and explode, they launch shock waves across the galaxy. Those shock waves accelerate particles to incredible speeds, sometimes very close to the speed of light. These particles become what scientists call galactic cosmic rays, and they travel across the galaxy for millions of years. Eventually, many of them reach the outer edge of our solar system. Without the heliosphere, those particles would reach Earth in enormous numbers. The invisible shield. This is why the heliosphere is so important. It acts like a giant magnetic shield. Most galactic cosmic rays are deflected or slowed down before they can reach the inner planets. The sun's magnetic field bends their paths and pushes many of them away. Inside the heliosphere, radiation levels are significantly lower than they would otherwise be. But beyond the heliopause, the situation changes instantly. Voyager's instruments recorded a sudden increase in cosmic radiation the moment it crossed the boundary. Not a slow increase, a sudden surge. It was like stepping from a sheltered room directly into a storm. That single observation confirmed that our solar system is not simply floating in empty space. It exists inside a protective magnetic bubble, and that bubble is constantly defending us from the harsh radiation environment of the galaxy, a changing shield. But the heliosphere is not permanent. Its size and shape change over time. Solar activity rises and falls in cycles. Roughly every 11 years, the sun moves from a quiet phase into a period of intense activity filled with solar storms and magnetic eruptions. During active periods, the solar wind grows stronger. The heliosphere expands outward. During quiet periods, the solar wind weakens and the heliosphere contracts. This breathing motion causes the boundary to shift billions of kilometers over time, and that is only part of the story. Our entire solar system is also moving through the galaxy. The sun orbits the center of the Milky Way at a speed of about 220 kilometers per second. Over millions of years, that journey carries us through different regions of interstellar space. Some regions are relatively empty. Others contain dense clouds of gas and dust. If our solar system were to pass through a particularly dense interstellar cloud, the pressure from a surrounding medium could compress the heliosphere dramatically. In extreme scenarios, scientists believe the heliosphere could shrink to a fraction of its current size. That would allow far more cosmic radiation to penetrate toward the inner solar system. It would not necessarily destroy life on Earth, but it could alter radiation levels in ways that affect climates, atmospheric chemistry, and biological evolution. Our planet's safety is not guaranteed by distance alone. It depends on the strength of our star, the loneliest explorer. Meanwhile, Voyager 1 continues its journey outward. Today, it is more than 24 billion kilometers from Earth. Its signal takes more than 22 hours to reach us. The spacecraft travels through interstellar space at about 17 kilometers per second, and it is still sending data back to Earth using a transmitter powered by a slowly fading nuclear generator. That generator was never designed to last this long, yet somehow the spacecraft continues to operate decades beyond its original mission. One by one, its instruments are shutting down to conserve power. Engineers carefully deactivate systems that are no longer essential, so the remaining instruments can continue working just a little longer. Eventually, the power will run out. Sometime in the coming years, Voyager's transmitter will fall silent. And when that moment comes, the most distant human object ever built will continue traveling alone through the galaxy. No signals, no contact, just silent motion through the interstellar medium. A message for the galaxy. Attached to Voyager is something else. Something designed not for scientists, but for the distant future. Bolted to the spacecraft is a gold-plated disc known as the Golden Record. It contains sounds and images from Earth, greetings in dozens of human languages, music from cultures across the planet, natural sounds like wind, thunder, laughter, and the beating of a human heart. The record was created as a message to any intelligent life that might someday encounter the spacecraft. The chances of that happening are extraordinarily small, but the record represents something important. It represents humanity's attempt to say, we were here. Even after Voyager's power fades, that message will remain attached to the spacecraft for millions of years, redefining our place in the universe. What Voyager revealed about the Heliopause changed more than just our scientific understanding. It changed our perspective. For centuries, humans imagined space as a silent void, a passive backdrop for the motion of stars and planets. But Voyager showed us something different. Space is structured, dynamic, filled with forces competing for influence. Our solar system is not isolated. It is a region of temporary dominance, maintained by the magnetic strength of our star. And one day, long after humanity is gone, the sun itself will change. In about 5 billion years, it will expand into a red giant star. The heliosphere will transform. The planets will be altered or destroyed. Even the protective bubble that shields us today will eventually vanish. But the discoveries made by Voyager will remain one of the most important moments in the history of exploration. Because for the first time in human history, a machine crossed the boundary of our solar system and told us what lies beyond. Not emptiness, not silence, but a vast, active galaxy filled with energy, radiation, and invisible magnetic forces. The edge of home. Voyager did not just leave the solar system. It redefined it. It replaced imagination with measurement. It replaced maps with physics. And it showed us something remarkable. The edge of our world is not defined by distance. It is defined by dominance. Where the sun's power ends, the galaxy begins. And somewhere out there in the darkness, billions of kilometers beyond, the last planet, a tiny spacecraft from Earth is still moving, still exploring, still whispering data back across the void. But the moment will come when that whisper fades forever. The signal will disappear into the background noise of the cosmos, and Voyager will continue drifting through the galaxy alone for millions of years. Yet the knowledge it delivered will stay with us. We now understand that our cosmic home exists inside a living magnetic shield, fighting constantly against the forces of the galaxy. And that realization changes everything. If this discovery changed the way you see space, stay with us. Because Voyager may be nearing silence, but the story of what lies beyond our shield is only beginning. I'd love to hear what you think about this, so drop a comment below. If you enjoyed our conversation today, please share this video and subscribe to help the channel grow. Every bit of support counts.